Problem 4 reads, Pizzeria Bon Appetito makes a triangular-shaped pizza with a base width 30 inches and height 20 inches as shown. Alice only wants a portion of the pizza and does so by making a vertical cut through the pizza and taking the shaded portion. Let x be the bottom length of Alice's portion and y be the length of the cut as shown. Answer the following questions. So we have a diagram here. First question asks, find a formula for y as a multi-part function of x for x is between 0 and 30. Sketch the graph of this function and calculate the range. So first thing we have to do is I put it on a coordinate plane so that we can more easily make equations for this line and this line. So I labeled this point A 0, 0, this point B 10, 20, and then found the equation of the line AB. And I did that by finding the slope by putting in each point into the slope formula and then getting a slope of 2. Then putting m and one of the points 0, 0 into point slope formula and getting y equals 2x for line AB. Then I found the equation of this line by doing the same thing, finding the slope, plugging it in, except this time using point 30, 0, and getting the formula y equals negative x plus 30 or y equals x minus 30. And so we just use those two equations as our multi-part function. The y equals 2x is going to be this line between x at 0 and x at 10. That's what the top line is for. And the bottom one is y is equal to negative x plus 30 or x minus 30 between x is 10 and x is 30. Here's a sketch of this graph. And then the range is 0 to 20 because it's the y value start at 0 and go all the way up to 20. Part B asks us to find a formula for the area of Alice's portion of a multi-part function for x for x is less than or equal to, or 0 is less than or equal to x less than or equal to 30. So we know that Alice's portion is between 0 and 10. We know that the area of a triangle is base times height over 2, or in this case, x times y over 2. And then we already know that y equals 2x based off of our line that we found earlier. So we just plug y, or 2x into y for x times y over 2 for the area, and we get the area is just x squared. Then we want to find the area between 10 and 30 for x. So what we did is we used the area we found earlier plus the base times height of another one of the triangles. If I just show you on here, this one, 20 and 20. And then we subtracted the area of one of the other triangles, and instead of, for the base, we use 30 times x, and then for y, we're going to use 30 minus x from our formula earlier. We use 30 minus x because if you look at the picture, we know that the entire bottom is 30, and this portion is x. Just to make things clear, what we're doing is finding the area of the unshaded portion. So 30 minus x is going to be the base here. So we go ahead and just simplify our terms and add like terms. So you get 10 squared turns into 100, 20 times 20 over 2 is 400 over 2, minus 30 minus x squared over 2, which you end up getting is 300 minus 1/2 x squared plus 30x minus 450. Combine like terms, you get negative 1/2 x squared plus 30x minus 150 between 10 and 30 for the value of x. Part C asks if Alice wants her portion to be half the area of the pizza, where should she make the cut? So for me, the easiest way to think of this question is just translating these English words into a formula. So Alice wants her portion to have half the area of the pizza. She wants her portion equal to half the area of the pizza. So we just know that we just created an equation for the area of Alice's portion, and then we've because we did a multi-part function, we can also find the area of the pizza using value x, which is our value x of or f of 30, because it's going to be between 0 and 30 is where our area is. We want to do it at 30, so it covers the entire length of this triangle. Next, what we're going to do is plug it into a formula. So here I have the one that we just found for Alice's portion, -1/2 x squared plus 30x minus 150. And then we do 1/2, and then the same formula, but we're using f of 30, so basically putting 30 in for x everywhere. So you can see that's where I did that, and then I set it equal to the original portion, or the original formula. And then I have, I go ahead and just simplify. We get 150 out of there is equal to -1/2 x squared plus 30x minus 150. Subtract 150 from both sides. And then we want to solve for x. The problem is that with this -1/2, it makes it a little bit harder. So I just multiplied this, or the entire side of the equation, by 2 in order to cancel out the 1/2. So we just end up with -x squared plus 60x minus 600 is equal to 0. And then I just put that into the quadratic formula in order to get to solve for x and get our two x values. I pretty much just plugged this into a calculator. I got 3600 plus 400 minus 600, which is -60 plus or minus the square root of 1200 over -2. The square root of 1200 can be broken up into the square root of 3 and the square root of 400, and the square root of 400 is 20, so we put that in front. That gets us -60 plus or minus 20 root 3 all over -2. And then if we solve for x, which just means dividing all these by -2, we get -30 plus or minus 10 root 3. And then if we go ahead and solve for the positive and solve for the negative of this plus or minus, then we get 47.32 and 12.68 for x values. But we know that 47.32 is not within the boundaries that we've been given for our triangle. The only one that fits those parameters is 12.68. So if Alice wants her portion to be half, then she has to cut it 12.68.